So this is the ISLM model. This is actually still very direct, so I believe this should be more like a bonus if we put it in exam. So I want to make this video short, and at the same time I want it to cover like two topics: ISLM and comparative static, the mathematical part. So that's the aim, so that we know that two topics is gone. So with the ISLM, you will be given your national income, which is Y, the national income function, and you will also be given your demand and supply of money. So what they will probably ask is probably the equilibrium, which is because IS is actually talking about the what is it called, national income. LM is talking about the money supply. So what they need you to do is to form a simultaneous equation from each. So with your Y, you can form your first equation, which is the IS part. Your Y is the IS part, the national income is the IS part, then the LM part is the money supply and demand. So you have to find your second equation with the money supply and demand. That means your money supply will be equal to your money demand. So in most questions, they won't give you your direct Y function. They will probably give you the consumption, the C, and the I, consumption and investment. So they believe that you should know that consumption plus investment will give you your national income. That's C plus I will give you your national income. That's how you get your first equation. While the second equation, they are going to give you your money supply. Sometimes they may not give you your money supply, your money demand function directly. They are just going to give you your transactionary, like this one, your transactionary demand for money, MT, and they are going to give you MZ, the speculative demand for money. They believe that you should know the three reason for holding money, and you should know that by the time you add the three together, it will give you your demand for money. So the transactionary and precautionary and the speculatory is what you are going to add together. But here we have just two, because they match transactionary and precautionary together as MT, and precautionary speculatory is MZ. So you'll be given that. So we are going to take an example now, probably one or two. Then we move to comparative static. Now, in this question, we have that the commodity market for a two-sector economy. A two-sector economy is in equilibrium when Y is equal to C. Okay, they are trying to just explain themselves. The main question here is, okay, we are giving our C as 48 plus 0.8 Y. Then our I as 98 minus 7.5 I. Then our this small I is simply interest rate. So our I, big I, is investment, C is consumption, Y is our national income, our income. So MS, which is money supply, is 250. MT, which is a component of money demand, is 0.3 Y, and MZ, the other component of money demand, is 52 minus 150 I. This I is still the interest rate. So how do we now solve the ISLM model? The first is to take these guys, the national income. There are two. So C and I. Add your C plus I to give your national income. So our C is 48 plus 0.8 I, 0.8 Y. So you are going to add it to 98 minus 75 I. So this is a number, we don't have any unknown with them, so you can add these guys together. 48 plus 98 will give us 146, I think, here. So that they come about this 146 here. So we have 0.8 Y here, and we have 75 I here. We cannot add those two together, so they'll stay on their own. 0.8 will stay on its own, 75i will stay on its own. And remember, everything gives our national income. So we are going to be having something like this: y, which is the national income, is equals to, by the time you add these two, we are going to have 146 plus 0.8 y, this is the continuation below, minus 75 I, this 146. Now this is what you get first for your national income, but you are not done yet. This is national income y, this is also national income y, so you can collect lifetime. So this guy can move here, so this will now be y minus 0.8, which is simply 0.2. It's changing to minus because it's crossing the equals to sign. So 0.2 will now be equal to 146 minus 75 I. So you can still actually rearrange. Because the aim is to get simultaneous equation. And remember, simultaneous equation do have two unknowns, and the two unknowns will be on the same side. So you can rearrange this with 0.2 y, then bring the 75 that have an unknown minus, to change to plus 75 I, then it will now be equals to 146. That's your equation 1. That's the first equation. So that one is set and you are good to go. Then go to the second equation, which is the supply, money. So money supply must be equals to money demand. These are money supply. That one is very direct, 250. That's our money supply, which must be equals to our money demand. What's our money demand? The addition of this MT and this MZ. MT is actually 0.3y, and MZ is 52 minus 150i. So you just add that to it, plus 52 minus 150i. That's MZ. So there's nothing you can add together here. You cannot add y and I together. Neither can you add anything to this 52. Only when this 52 cross this side to come and meet 250. But I'll just prefer to move this one and this one here, so as to form like this type of equation, and move 250 here. So 250 will come here, these guys will come here. So I'm going to have minus 0.3 y, then this one also comes, minus 150 comes, it becomes plus 150i equals to, then 250 comes like that, 52 minus 250, that will be minus 198, I think. Yeah, minus 198. So these are two equations, equation 1, equation 2. So you now solve simultaneously. Well, the fastest way to solve simultaneously is definitely calculator, but I think, to be on the safer side, we are doing theory. Just solve it out. You can use elimination method, substitution method, and if it's mathematics that is easier for you, use that, so that you won't be skipping any step that might actually carry marks. So if you just use calculator and you do it directly, yeah, you get your answer, you get an answer, the man might actually have marks that are hidden in that step. So it automatically means you have lost those marks. So it's better you just write everything down. It's better you even show your workings. You may not show your workings in your main answer script. You can show it at the back, or there are some workings that you might decide to show at the side. You can just put a note box beside your work, so show it at the side. All these things actually pass messages to the marker. The marker are human being, and you can play with their psychological behavior. So by the time he is seeing your work unique, everybody just writing answer, writing, but he sees your work unique. Probably while you are solving, you just have a box beside it, neatly drawn. then you have the workings for number 1, the box beside it, number workings. Then you show some of your workings that you feel okay you may not need in your main work, so that your main work will not be dirty. So it's actually personally saying that this person actually knows what he or she is doing. So he might not add mark for you, he might add mark for you for that, he might not add mark for you, but it's actually passing message to him that this person know what he or she is doing. So when he's marking, he's conscious that okay, he actually know what he's doing. So some stuff that he may actually might have missed for you, might actually mark it right for you. So sometimes just do that to be on the safer side. So I advise, don't use calculator. So but yeah, we are just going to just use the answers that we have here to save time. So but your calculator thought is still useful. You can actually check your answer with calculator. That's very allowed. So they solve simultaneously. Let's see what they have here. So they are also checking their step. In case you don't know how to do simultaneous equation, you can quickly just check it out in any material that you may have access to. They are not something hard. So we have our I as 0.08 and we have our Y as 700. So our I as 0.08 and our Y as 700. Let me clear this. So this is our Y 700, our I at 0.08. So if you solve your simultaneous equation rightly, you are also going to be getting 700 and 0.08. Now other things that you might be asked, which they also do here, is to now find the value of C. Remember, we are given a function for C, that C is 48 plus 0.8y. That's the function for C. So by the time you get our Y at 700, just replace the Y with 700. That is if you are asked for the value of C, your consumption. If you are not asked, just leave that part. The same thing goes to investment. Investment is 98 minus 75I. So if you are asked to find the value of investment, just replace your I with your answer here. That's 0.08. Same thing goes to money supply. Actually is a figure 250, so you don't need to actually change anything there. But for money demand as empty, that's the transactionary part. The money the transactionary and precautionary part, which is 0.3y. So you change your y with this, and the same thing goes to mz. You change, then you get your value for each and every one of them. So that's basically what ISLM model is all about. Let me believe that we have gotten it with this. So you can solve more questions in Schwamms. We have about 2 other questions in Schwamms here. This is Schwamms, so we have about 2 other questions. You can solve them and see if you can get your answer. So I would like to do much time on that because it's quite direct. So let's go to comparative statistics. So this is comparative statistics. Now this comparative statistics is actually what we have been doing before. Actually, it's basically just differentiation. Then you are applying just like static and equilibrium analysis, where you are equating your demand and supply. The same thing we are doing here. We are doing something similar, but we'll now be differentiating implicitly, in some aspects. And also there's a part that leads to matrix, usually Jacobian matrix. But we're just going to look at the basics because I'm not sure it's worth wasting time on this, because I'm not sure the man will set question from this though, but this is not to be risked. But we just want to get the basic concepts, the calculation part. Then if you have the time, you can then go further. And if you don't have the time, just study matrix, know the basics of this. At least you'll still be able to have an idea of what to do in the Jacobian part. And I believe matrix shouldn't be too difficult for us, as the man spent a lot of time on matrices. So let's look at comparative statistics. I said earlier, we are basically looking at equilibriums, different equilibriums with this comparative statistics. We are comparing different equilibriums. So if you want to look at this particular demand function, for example, this is QD, the demand function, and this is QS, the demand, another function, the supply function. Now we want to look at these two functions and see how we can be able to use comparative static to derive a particular function for P. We are coming here. In fact, we are still even coming here. So as I said earlier, we are equating one, and also we are differentiating implicitly. Equating demand and supply function is something that we are all familiar with. It's only implicit differentiation that I feel some people may not be familiar with, which I'm going to show you how they do it here. So let me just get my pen. So this is the demand function, the supply function. When you equate it, you are definitely having m minus n, then the p, plus small k and y is equals to a plus bp. So that's just you equating it. So that's how we come about this that they have here. So they equated QD and QS, they come to this. Now the best thing I'll ask you to do here is to collect like terms. Now all of them are actually letters. So how do we collect like terms? Look at the letters that are common. Basically this is the one that is common here, P, the one with P, as in this guy, MP and BP. So equate them, as in bring them together, see them as like terms. So bring them together on a particular place. So we want to make the P the subject of formula. So we have M plus KY, because I'm moving this minus MP to the other side, but I'm moving A to this side. So this will be minus A, will now be equals to, then I have my BP here. So the sign is not changing because it's not moving, but this MP, I move it here, so it's going to change to plus NP. So we factorize, so this can actually be factorized to P is common there, just bring P out, B plus N, so bring P out. By the time you expand, you'll notice that B times P will give you BP, and N times P will give you NP. So we are still doing the same thing. So we can now divide both sides by B plus N to make P the subject of formula B plus N. So that's how they come about this final equation. So we have M minus A, is M minus A, this is here, then plus KY, this plus KY, then this divided by B over N, this is it, by dividing both sides by B plus N. That's how they get that. So we have made P the subject of formula. So let me clear this. Clear. So we have made P the subject of formula. So let's continue. Now this is the point where we are now differentiating. Now it is after they differentiated, they are looking for dy dp that they get this. All you need to do is to use quotient function, as in quotient rule, in order to differentiate this particular one. Remember, this is a division, so you are using quotient rule. I hope you can still remember that, but if not, let's quickly try and remember. So the quotient rule is simply v du dx minus u dv dx over v square. So that's basically what the quotient rule is all about. So we are going to represent the one up here as our u, we are going to represent the one down here as our v, and notice we won't have the x here even because we are not differentiating with respect to x. So we won't have the x here, but this is just since we basically use the y dx for our solution, so that's why this formula is what is rightly in my head right now. So you just change the x to whatever you are differentiating to. So here now we have u, this is our u, so our u is equals to m minus a plus ky. That's our u. So these are u, these are v, these are u, these are v. So u v du dx, it simply means this v, that's b plus n. This one you are differentiating explicitly. Then I will show you how to do the implicit one so that we're able to get a formula though. So this is b plus n, that's our v. Then du dx simply means differentiate this one with respect to this y, because remember we are actually doing the p dy. So that will be with respect to this y, that will be k. But when you differentiate this, it will just be k. Then minus, what's our u? Our u is the one up this particular function. So m minus a plus ky. Sorry, trying to manage the space. Then times differentiation of the one below, b plus n, with respect to y. Now there's no y here, this simply means this is 0. So automatically all this one here will turn to 0 like that. But let's continue. Over v squared, that's b plus n squared. B plus n square. B plus n square means b plus n times b plus n. So this one is already 0. So it simply means this square will cancel this b plus n. So that's why we have k over b plus n that they have here. K over b plus n that they have there. So that is not differentiating. They are differentiating explicitly. Now the implicit one will help us to be able to derive a formula that will make it easier for you, instead of you just going through all this differentiation.
Sorry, what?
So differentiating implicitly, the only difference is just that, you know, we equated this particular equation, and then the two of them, qd is equals to qs. Sorry, I'm using a too deep line. Qd is equals to qs. We equated the both of them. Now the difference now is that when you equate the both of them, you set them equals to 0, meaning that you collect all of them to one, you bring all of them to one side, then you make it equals to 0. That's exactly what we have here. So after equating, this is the demand function, demand or supply, one of the, this is the supply function. Then this is actually a plus bp, but they are on this side, so you move them to this side, it turns to minus, so this will be equals to 0. Then you now differentiate this implicitly. So after differentiating implicitly, they were able to come to this formula. But let's leave this formula. Let's see how do we differentiate implicitly. That's the question here. So this is m, np, ky, a, bp. We are actually doing dp dy. That's what we are doing, dp dy. So when we want to differentiate implicitly, before they could come to this formula, they have to differentiate, and was able to derive a formula after they study different implicit differentiation. They are able to get that, okay, so we go into the long process, we can simply use this to get our answer for implicit differentiation. But how do they differentiate implicitly normally? So this np, ky minus a and bp equals to 0. That's what we are differentiating implicitly. Remove this f for now. This f is just representing this one here. So we have m minus np plus ky minus a minus bp equals 0. Now you differentiate each one of them with respect to y. Differentiating m with respect to y is automatically 0. Minus np, differentiating with respect to y, is supposed to be 0. But because it is implicit differentiation, and this p is the order, this one is assumed to be constant, this p is not assumed to be constant, so we are going to differentiate this p with respect to p here. Although we have to differentiate with respect to y, we are going to differentiate with respect to p here minus n, but we are going to take note, put it in front of it, that it's dp dy. So anyone with p, anyone having p that we are now differentiating with respect to p, you always put dp dy in front of it. But if it is y, you don't need to put dp dy, just differentiate normally. But if it does not have p or y, it simply means it's constant, it will be 0. So that is why this m is 0. Minus np becomes minus n dp dy, because you differentiate with respect to p. Now we are differentiating with respect to y. This one will not have dp dy, it will just be plus k. So this one is good to go. Now minus a, it is constant, it will change to 0. Now this minus bp also have dp dy, so it will come down to minus b. Differentiate with respect to p first, then you put dp dy, then everything equals to 0. There's no space for my 0 here, so this 0 is gone. 0 minus this, so this 0 too will go. So now have minus n dp dy minus n dp dy, then plus k. I want to collect like times this b dp dy minus b dp dy. I want to bring this with it, so minus n dp dy minus b dp dy dp dy equals to, then this k I bring it like this, turn to minus k. So this 0 is gone, so this k comes like this, turns to minus k. So dp dy is common here, dp dy is common here, so make dp dy the subject of formula. So we are going to have minus n minus b, then everything dp dy. By the time you factorize dp dy, everything will be equals to minus k. So divide both sides by minus n minus b. Let me clear, okay, let me don't clear the board yet. So we are going to have dp dy will now be equals to minus k over minus n minus b. So by the time you factorize and bring out, this one is minus k, take note, minus k. By the time you factorize and you bring out your minus, it's going to be minus k over minus, when you bring out minus from here, it will be n plus b, n plus b. Sorry, I just want to manage this space, that's why we are squeezing it. So minus cancel minus, so we have k over m plus b, which is the same thing as k over b plus n, whichever comes first, doesn't matter. So we have k over b plus n or k over n plus b, still the same thing. So can you see that we get back to the same thing? Now if you look at it, when you look at use this formula, so in case you cannot use this, you cannot remember this formula, just differentiate implicitly. I'll try to do one more example for implicit differentiation so that we get it well. So we have minus fy over fp. So if you use this formula, you see that you just get this directly. This simply means minus fy simply means just the minus differentiation of this particular guy, this particular function with respect to y. So minus fy differentiate with respect to y, that's k. So that will be minus k. That's it. So when you differentiate with respect to y, that's k. Now differentiate with respect to p. Remember p is here, p is here. So the two of them you are doing. So this will give minus n. When you differentiate with respect to e, p minus b. So can you see that we have come back to this? So you cannot get this. So any one of the two, when you differentiate implicitly, that's the one that you have to use dp dy wherever you are differentiating with respect to p. But when you use this formula, you just get your answer directly. So let me clear this and take one more example. Let's go to solve questions. So I'll do this in a new board so that it won't be modeled up again, so that it to aid a better understanding. So all this ones I feel like it's not for us, including this concave programming, not for us yet. So it's only the basic part. So I think this is the same thing as what we just finished doing now. So we are not doing this. Yeah, it's the same thing. So we are not doing this. So let's try this. Let's try this. This one seems to be pure figures. Okay, this is the 13.1, 13.2. So let's do this. Let's do this. So we have that. Well, my network is bad. Seriously bad. The Jamboard is not working. What's up? So let me try to reconnect back. Jamboard, please. So let's take this as a second example. I'm just going to, let me see, I want to move this question. I want to move it to Jamboard. So let me take this question. So I'll put it here. So that's our question. So here we have enough space. So there's a question. Then we are given QD, QS. This is a little different from the first one we did though, because this one have more than 1p. We have price of the complement, price of the substitute, price of the input. It's more like the same thing, so it's nothing to worry about. So the first thing is that, okay, we are told that price is this, we have to find the equilibrium price. This one is very simple. Equilibrium price is just equate your quantity demanded to your quantity supplied, then make P the subject of formula, as in this P, not the PCU, not the PSO, and not the PI, just the P alone. This is the P alone. Where's my lighter? So just this P alone, and you see this P alone. So that's when we are making the subject of formula. So how do we do that? Like I said, it's simple. We are just going to have M minus N, then P minus C P, so it'll be C plus S, wow, S P, then S, then everything will be equals to our quantity supply A plus B P minus I PI. So our aim is to make this P the subject of formula. This is also it here. We want to make P the subject of formula, so that should be easy. So we have M minus C. I've taken away this one like this, so PC plus S PS. Then A2 comes like this, so it becomes minus A. I and PI2 comes like this, it becomes plus PI. Is equals to, then we have our BP here, BP. Then remember this minus NP comes like this, becomes plus NP. So you can factorize this one. So we are going to have, and rearrange it to, we are going to have P, B plus N, B plus N. By the time you factorize, I mean this side, this is the one I factorized, B plus N will now be equals to everything we have here, M minus C PC plus S PS minus a plus, well, I've omitted this something here, this I plus I pi. So yeah, partially done. So just divide both side by b plus n, you get your answer, b plus n. So you divide this one to by b plus n, as in everything by b plus n, without space again. And my writing is horrible on this particular board, very horrible. So we have b plus n here, so our p will be standing alone because this is now gone. So this will be our equilibrium price, this one here. So it's actually simple, just that we have so many letters, so it makes it look complex, but just do it step by step. Try not to jump any step, so this step by step, you'll be able to get it. So that's our equilibrium price. One problem is done. So let's go to another one. So let's go to another problem. So let me just clean all this. So let me bring my question back. So the second question, that's the B part, says find the comparative static derivative resulting from the change in PC and PI. Find the comparative static resulting from the PC and PI. Now this one, you just differentiate. Well, we will need our answer. We're gonna copy it. So the answer you just got now from 1, that's your equilibrium price. You actually need it. You want to differentiate now. You differentiate partially with respect to PC for you to get this comparative static derivative for PC. Differentiate partially for PI for you to get that of PI. So let me just go and bring it from Schramm's because I've actually cleared it off. That's the answer we just got now. Let's take it from Schramm's. This is it. So let me also screen grab it. So I put it here. So this is it. This is your first answer for A. So differentiate partially. We have not gotten to where we are going to differentiate implicitly. Then I'm going to show you implicit again. So differentiate partially with respect to PC. So for PC, we are just going to have differentiation of this with respect to PC. Now this is a quotient function, so we are going to use quotient rule. So it is what? V du dx minus u dv dx over v squared. But here now our x is no more x, is our PC that we are differentiating with respect to. So it's not going to be u, this is our u. Let me still write it out. V du dx du dx minus, we are just going to do one of it. You can do pi by yourself once you have done PC. So minus u d v dx, then everything over v squared. So what is v? That's b plus n. The one below is v. This is u, this v. B plus n, b plus n is our v. Then the u dx simply means differentiate the one up with respect to what you are looking for. We are actually looking for PC with respect to PC. So that will be partially differentiate though. That will be minus times minus c. This times, don't make that mistake please. Times minus c. So we are done with this side. So it made this one. Then everything minus u. What's our u? Everything here. I don't think I'm going to write that because I think it's going to give us 0. So everything here, you simply write everything here. So to save time, that's why I just put u. Then dv dx is the differentiation of this with respect to still this PC, but there's no PC here. Simply means this will give us 0. Then everything over v squared. What's our v squared? B plus n. B plus n squared. Once again, this is not yet partial. We are still differentiating. This is not yet implicit. We are still differentiating normally. So the next one is what we are going to use implicit for. So this one is now 0, so it's gone. So this square will cancel this square, so we now have minus c over p plus n. That's our final answer for PC. So you now do the same thing for PI, which we are not going to do. So just do the same thing for PI now. So instead of you differentiating partially with respect to PC, differentiate partially with respect to PI. So the only difference between this one and the first one we did is that this one have many prices. The first one just have one P. So that one just differentiate with respect to that P at this particular stage. So I'm not going to clear everything, I'm just going to clean them off. So we go to the next one, which is find the implicit function for the equilibrium condition. Now remember I said you can use that formula minus z y over z p, that formula actually for implicit function, but you can also differentiate implicitly directly. The reason why you need to know implicit function is that in case you forget the formula, one. Number two, who knows, there may be a question that will say differentiate implicitly. Don't just use the formula directly, you'll be losing lots of marks. They want to see your steps. So that's why you need to still know this implicit function. So while we are doing this comparative static, we are even starting to do part of implicit function. That's simply what we are doing. So let me clear this board. Okay, before I clear, let me copy this guy because I need it. Do I need it or this one? Which one should I copy? Okay, let me copy this one. C. Okay, so perfect. So my question is back. So let's differentiate implicitly. So remember, when you are differentiating implicitly, you are still equating this one and this one, but you now set it to 0. So we are simply having m minus n p minus c p c plus s p s is equals to qs, so qs, which is a plus b p minus I pi. So just wish I can write paint directly on my screen. This is frustrating using mouse. So this is qd is equal to qs, like the first step you did, but instead of making p the subject of formula, now you want to bring all of them to one side and equate it to 0 before you now start your implicit differentiation. So we are going to have m minus np minus c pc plus s. These guys are not moving, so that's why they are still the same thing. ps. Just pardon my horrible writing. Then sorry, this is no more equal to, this will now be minus a by the time a goes to the other side. bp2 will turn to minus by the time it goes to the other side. Then this will turn to plus by the time it comes to the other side. ip1 equals 0. So that's that. So now let's now differentiate implicitly. Now if you want to use the formula is, can I remember, minus z, no, it's f minus f y. I think formula for differentiating implicitly over fp for this particular one. Now, but here we are no more using y. What we are actually focusing on in this find the implicit function of the equilibrium condition is this p of s ps. So this y is now p of s. Yeah, no more using y. So that is if you are using the formula. So let me clean it and write it well. Y is now p of s. Yeah, so that's what we are using now, because we are not giving y here. So that's it. So and this is p. Now if we are using this formula, let's see what will be our final answer before we now differentiate implicitly. So this is minus p of s. From this particular equation, this particular guy, so we differentiate with respect to p of s. So all this one like this are gone, it just remains this one, that will be s. Let me write it here, s. Your minus, remember to put it over this minus, put it. Then fp, differentiate with respect to p. This p here, not pc, just a normal p. This bp, so that will be minus n. Then for this one gives minus n. Then for this one give minus b. So by the time you factorize, it's going to give you s over n plus b. So that must be our final answer. So now let's differentiate implicitly and see if we are getting the same thing. Now differentiate m. Remember, when you are differentiating implicitly, you are focusing on ps. We are differentiating with respect to ps, but you are focusing on p and ps, as in what we have here, ps and p. You are focusing on those two. So others will be seen as constant. So this m is constant, it will do. It is not 0. Now minus mp, we are differentiating with respect to ps, but this mp we are going to still differentiate with respect to p, but now put the ps dp. So that will now be minus n. By the time you differentiate with respect to p, then you put the ps over dp. So that one is done. So minus cpc, all this one will be seen as constant because it is not ps, neither is it p, so it will be seen as constant. 0 is gone. Plus sps, now this is ps. This one, now you differentiate this one with respect to ps, but you will not put the ps dp because that's actually what is our main focus. So that will now be plus s. That's it, just plus s. Minus a is constant, is 0. Minus bp, now p is not our main focus, but it's also what we are interested in because it's here. So we are going to differentiate with respect to p, then put the ps dp. That will be minus b d ps dp. Then plus ipi. So this is changed to 0. So let me just put equals to 0. This equals to 0. This one is changed to 0, so we don't need it because it is pi, not p. Is it ps? So this is what we have here. This 0.2 is gone. We don't need it. So you can now collect like times. Make the ps dp the subject of formula. It simply means move. This will now be, let me see. Can I manage here? Let me manage it. Minus n dps dp ps dp. I wish I can just find a way to just bypass this mouse issue for typing. So minus n dps dp minus b dps dp dps dp. So that just as long as we have written dp, everything equals to, then s comes to this side, becomes minus s. 0 minus s, 0 minus s. So let me just clean some parts. Or are we still needing this? Okay, let me move my question away and continue up here. So I'm going to continue up here. So by the time you factorize these guys here, this minus n dps blah blah blah, we are going to have the ps over dp, then everything in brackets. By the time you factorize minus n minus, what's the second minus b, then everything equals to minus s. So divide both sides by minus n minus b, it will cancel this one, so this one will be minus n minus b. So you can see that we have come back to this minus n minus b. So by the time you now factorize minus out, you are going to have s equals to n plus b, s over n plus b. So check the answer here, you can see that we have the same thing. So that's how to do implicit function, and also how to do it directly using the formula minus f y. That's if it is y that you are given, but here we are not given y, we are given ps. That's minus s fps over fp over fp. So that is that. So that's it. Let's stop there.